Good morning, everyone. Today's our topic is impurity defect. This is last type of defects in solid. Now, generally, this defect arises when foreign atoms or ions are present in the lattice site. Okay, generally, in this one you can take example that NaCl crystal, okay, containing a little amount of strontium chloride. So it means that this one is an impurity. The NaCl generally strontium chloride added in, okay, sodium chloride. Okay, now in this one just see chloride and chloride negative ions are same. Okay, the generally positive ion is different, so strontium replaces sodium. Now just see in this crystal Na positive, Cl negative, Na positive, like this. So after this Na positive will come, but now strontium chloride, so strontium replaces sodium. Okay, now each strontium replaces two sodium ions and create a vacancy over here also. Why two sodium ion? To balance it, or to balance the charges, because sodium is Na positive and strontium is, okay, that one is 2 positive. So generally each strontium replaces two sodium ion. Okay, now this one is regarding to impurity defect. Okay, our next topic is, that one is regarding to doping. Okay, doping, simple. It is a process by which impurity is introduced in semiconductors to enhance their conductivity. Okay, it's not that doping. If you are thinking about physical education, कि generally in that one for athletics or for some different sports कि injection लिया या something. Okay, this doping is related to introduction, yeah, when impurities are added. Simple, that this doping, so it is a process by which impurity is introduced in semiconductors to enhance their conductivity. Okay, why? Because in case of semiconductor only we can change their conductivity, either increase or decrease. Okay, now doping can be done in two ways, because when you introduce impurities, okay, so for that we have method. So how can be done doping? So generally doping can be done in two ways. Okay, for this you have to learn group 13, 14 and 15 elements. If you know group 13, 14 and 15 elements, then this process is very easy. Now first of all, I think you know that one is group 13 element. Now after that group 14, and next one is group 15 elements. Now group 13, it's a boron family. So simple, bangan, aloo, gajar, in, thela. Let's see, simple thing. Now 14th group, it's a carbon family. Choti सी गाड़ी सबने पकड़ी. Now in this one group 15, it's a nitrogen family or nicogens. That one is nahi papa ashish sabse bigda. All these are shortcut we have done already in 11th class and even in 10th also. Okay, now in this one, now check your first work is you have to count number of electron. It's a 13th group. Okay, it means, okay, general configuration in outermost shell, how many electron? Okay, number of electron is 3, here number of electron is 4, and here number of electron is 5. Okay, now doping can be done in two ways. How? First of all, okay, now in case of this one, whenever lower group is doped with a higher group, okay, lower group doped with a higher group means when group 13, or either you can say that one is when silicon or germanium is crystallized with a group 15 elements. Okay, means either you can say in this one, that one is when group 14, this one is a lower group, it's a center group. Okay, when this group is group 14 is doped with group 15 elements. Okay, now just see in this generally semiconductor. Okay, so we have two metalloids. It's a either it's a silicon, either it's a germanium generally we use, and here either we use phosphorus, either it's a arsenic. Okay, now in this one, when 14th group is doped with 15th group, okay, 15th group element, okay, either it's a phosphorus or arsenic, then okay, generally N type semiconductor is formed. Now in this one, that N type semiconductor Okay, in this case, N-type semiconductor is formed. Now, first of all, N-type semiconductor is formed. Okay, what is N-type of semiconductor in this one? Actually, N-type of semiconductor means N represents, okay, it's N is for -1 and generally electrons are negatively charged. So in case of N-type semiconductor, electrons are responsible for conducting uh, generally for conducting electricity. Okay, and that is N-type semiconductor. So in this, okay, 14th group is doped with 15th group, and in this electrons are responsible for conducting electricity. Now question arises, how? Okay, now just see, in case of 14th group, now suppose it's a silicon, how many electrons we have in the outermost shell? It's a 4, because 4 electron in the 14th group. And in case of 15th group, because it's doped with 15th group, now just see, 1 2 3 4. Suppose pairing of 4 group. Okay, this one is, you can take any example, either it's a phosphorus or something, then 4 electron combined with 4 electron of 15th group, but 1 electron is extra. If you will see, this 1 electron is extra. So this extra electron is responsible for conducting electricity, and electrons are negatively charged. That's why this type of semiconductor is known as N-type semiconductor. Okay, now second thing is another point, when, now just see, when group 13 is doped with group 14. Now in this case, or either you can say that one is group 14 elements is doped with group 13 elements. Now in this one, now just see 14, because this one is a common one. So 14th group, either you can say group 14 is doped with group 13 elements. Now in this example for group 14, okay, we have silicon, we have germanium, and for group 13 we have boron, we have aluminium. Okay, now in this one, so when this 14th group is doped with 13th group, so that type of semiconductor is known as p-type semiconductor. Okay, so in this case, p-type semiconductor is formed. Okay, now in case of p-type of semiconductor is formed, in this one, okay, why p-type of semiconductor is formed? Actually in this, now just see, again, either it's a silicon, how many electron? It's a 4, when combined with 13th group. Okay, and in 13th group we have 3 electrons only, so obviously any 3 electron will combine, generally they will form pair. Okay, but here this site, when there is no pairing with that group, okay, so here its hole is created, means it's a vacant space. Okay, so generally that one is known as hole, and in this case hole is responsible, okay, for conducting electricity, and generally holes are positively charged. Okay, that's why this type of semiconductor is known as p-type semiconductor. Okay, so this one is regarding to doping and how doping can be done. Okay, so on this basis, generally we have two type of semiconductor, it's an N-type semiconductor and p-type semiconductor. Now in this, one short question is there, but it's important. Okay, we have, okay, 12, 16 and 13, 15 compounds also. Okay, it's a general one more topic. Now just see, in this one, one is 13, 15 compounds. Now simple, what is 13, 15 compounds? It's a 2017 question, board mein aaya hua question hai, it's important. Okay, so generally 13, 15 compounds means simple, when 13th group elements treated with or combined with 15th group elements and form compound, so that type of compounds are known as 13, 15 compound. You can take example. Okay, now in this, for example, either it's a ALP, aluminium phosphate, either it's a GAS, this one is GAAS, it's a gallium, and this one is for arsenic. Okay, so we have so many examples when 13th group combined with 15th group, so that type of compound is known as 13, 15 compounds. Now another one, we have 12, 16 compounds. Now in case of 12, 16 compounds, okay, in this, that generally 12th group elements are combined with 16th group element, okay, to yield some solid compound, okay, which are referred as 12, 16 compound. Now just see, it's a 12th group. 12th group is generally, okay, carry which elements? It's a zinc, cadmium and mercury. So in case of this, zinc combined with this sulfur, 16th group. Now either it's a CDS, either it's a Hg, Te, etc. Okay, so when 12th group is combined with 16th group, so that compound is known as 12, 16 compounds. Okay, thank you.